Okay, I'm going to take you through some algebra reminders. These are all things that we've learned already. Sometimes it's distributing, quadratic formula, factoring, substitution, radicals, things like that. Just things that are going to pop up in this unit that I thought maybe you could get a quick review of. Okay, so I'm just going to work through these. So number one, I'm going to do x plus 3 quantity squared. Now remember, when you have a plus sign here, you can't just square the x and square the 3. If you want a reminder of this, what you can do is x plus 3 squared is really x plus 3 times x plus 3. And then we have to FOIL that, which really just means we're going to distribute or multiply. So we're going to get x squared when we take the x times the x times the 3, and get a 3x. And then we're going to distribute the 3. And then we'll do 3 times 3 and get 9. And we end up getting x squared plus 6x plus 9. And again, if you remind yourself of doing enough of these, you're always going to get the 3 times the 3, and you're going to get double this because you're going to get x times a 3 and then a 3 times an x, and of course you're going to get the x squared. Okay, so you're going to get this. And this will come in handy when we do a problem like this. Now this looks like the Pythagorean theorem where, we know one side is x, another side is x plus 7, and the diagonal is x plus 8. Okay, so to do a problem like this, we just have to use that algebra piece. So that's just x squared. And again, being able to do this is being able to say then that's x squared plus 14x plus 49. Again, that's me distributing x plus 7 times x plus 7. And then x squared plus 16x plus 64. Now I'm going to solve this equation. It looks like this is a quadratic. Quadratic equations, we're going to get everything on one side. It looks like this side will be easier to get everything on the left side. So this is x squared plus x squared, which is 2x squared. But then I'm going to minus that x squared. So I'm left with just an x squared. That's a plus 14x and a 16x. So I'm going to subtract and get 2x. And this is 49. What's that? Minus 64 is going to make that a minus 15. And we have it equal to 0. And at this point, we can use the quadratic formula, or we can solve by factoring. This one's going to solve by factoring pretty easy. So we're looking at factors of 15 that have a difference of 2, and let's make the bigger one negative. So we get x minus 5 and x plus 3, and that gives us two solutions, 5 and negative 3. Now, up here, these do solve this equation, but if this equation really is like the equation that comes from some triangle, we probably are going to ignore that negative one, right? Because we can't have a side length be negative, so that would be an extraneous solution. It does solve this equation, but it might not solve the real world. Okay, now let's look up here at just a normal quadratic equation. This quadratic equation, unfortunately, doesn't factor. Now, if it doesn't factor, then to solve a quadratic equation, we're going to need the quadratic formula, okay? Which is minus b plus or minus the square root of b squared minus 4ac all over 2a. And it may or may not simplify. It may just turn it into a decimal, and that's okay. So these are the coefficients a, b, and c, right? Quadratic, linear, constant. And then let's go ahead and just do this then. So the opposite of b, the opposite of 4, is just negative 4 plus or minus the square root of b squared. That's 4 squared. That's just 16 minus 4 times a times c all over 2 times a, which is 4. Okay, let's simplify in here. So this is negative 4 plus or minus, and this is what? A negative 4 times a 2 times a negative 5. So it's going to be a positive. That's going to be a positive 40, and then 40 and 16 is going to make 56. Okay, over 4. Okay. That is going to go maybe a little more simple. So I'm going to simplify that. So that's negative 4 plus or minus the square root, and that's really just, it's 4 times 14 all over 4. And then we can simplify that a little more and make that negative 4, the square root of 4. It's going to be 2. And then since all of these things have a 2, I can reduce this. And I can make this negative 2 plus or minus the square root of 14 all over 2. And that's as simple as it gets. Now, if you wanted to turn it into a decimal, you'd have two solutions. Negative 2 plus radical 14 over 2 and get an answer. And negative 2 minus square root of 14 over 2 and get an answer. This is going to be the exact form, and that's going to be fine. Okay, so that's solving a quadratic that doesn't factor in this case. Okay, let's look at this. We somehow know maybe that this comes from the area, you know, x times y is some 40, and this comes from some perimeter equation or something. But we know that 40 equals x times y, and we know that x plus y equals 14. This is a system of equations. So I'm going to take this one and I'm going to solve it for y. So y is going to equal 14 minus x. A lot of people call it box and ship in Algebra 1. It doesn't really matter. Really, it's just substitution. We're going to say that y equals 14 minus x, and we're going to come over here and say 40 equals x times, well then our new y value, 14 minus x. So I get 40 equals, and I'm going to distribute this, 14x minus x squared. I'm going to move everything to the left side of the equation because I have a quadratic, so I'm going to get x squared minus 14x plus 40, and that equals 0. Okay, and now I have to think, okay, does that factor? If it doesn't factor, I need to use the quadratic formula, but this one does factor. This is going to be x minus 4 and x minus 10, so I'm going to have two solutions, 4 and 10, and that really is both solutions up here because x and y are symmetrical because it doesn't really matter which one is which. If x is 4, then it makes y 10. If x is 10, then it makes y 4. Either way, my two solutions, if this is some sort of rectangle or something or other, are 4 and 10, right? 4 times 10 is 40. 4 plus 10 is 14. So those are your solutions, okay? So that was me solving this by substitution and then solving by factoring. This was solving by factoring. This one couldn't solve by factoring. Remember, it's a quadratic. So I'd use the quadratic formula. This isn't even an equation, right? This is just an expression. That's just me simplifying that. Okay, so take a look at those. All right, let's do the next set. All right, so the next set, let's look at this. It's similar, okay? So this looks like some sort of quadratic formula, or excuse me, this looks like some Pythagorean theorem, and this is some maybe perimeter equation. I don't know, but I still have two variables and two equations, and I'm going to solve with substitution. I'm going to divide everything here by 2, because why not? And then I'm going to solve this one. Let's solve this one for x. X equals 10 minus y, and let's go ahead and then substitute that in here. So I get 10 minus y squared plus y squared equals 58. Okay, now again, reference that first page. If you have 10 minus y squared, it's 10 minus y times 10 minus y, which is going to be 100 minus 20y plus y squared, and then the y squared and the 58. Again, this is another quadratic. A quadratic, we're going to get everything on one side of the equation. So I'm going to take y squared and y squared, those are my lead terms, and get 2y squared minus 20y. And then I'm going to subtract this 58 from the 100 and get, what, plus 42 equals 0. I notice that there's a factor of 2 in all these things, so I can divide everything by 2. And 0 divided by 2 is just 0, so I can just divide both sides of the, I meant to say a 10, 10, and 21 equals 0. And this again is going to factor again, that's a 10. This is going to do y minus 3 and y minus 7, right? 3 and 7 make 21, and 3 and 7 add to get negative 10. So this means that y equals 3 or 7. But if y is equal to 3, then x is equal to 10. And if y, I don't even know why I said that. If y equals to 3, x equals to 7. And if y equals to 7, then x equals to 3. Either way, that's your solution. And you can check to make sure that works, right? 7 squared plus 3 squared is 58. 2 times 3 plus 2 times 7 is 20. All right, so we solved it. Again, we solved the system. Okay, this guy right here, these are our 3 trig situations, and they're just going to pop up sometimes. Maybe you know the diagonal of a rectangle and you want to know the side length, or you know the width of a rectangle and you want to know the diagonal, and you know the angle. It's just going to come up. Okay, so let's write SOHCAHTOA as a reminder. Remind us of SOHCAHTOA that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So this one looks like it's going to be cosine. I have this angle, this is the adjacent, and this is the hypotenuse. So we say that cosine of 20 equals x over 10, and all we have to do then is multiply both sides by 10 and then type that in our calculator. And x, oh, if I type that in, I should get something like 9.4. Okay, now let's look at this guy. This is going to be a sine because I have this angle. This is opposite an hypotenuse, so that tells me to use sine. Sine of 40 is 12 over x. X is in the denominator, which is a little annoying, so I'm going to multiply both sides by x, and then I'm going to divide by sine of 40, and then I'm going to type that in on my calculator. Okay, so I'm going to take 12 and divide by sine 40 and get 18.7. Okay, and this guy is the other example, right? Variable in the numerator, variable in the denominator, or the variable can be the angle. This time I'm going to use tangent. Why? Well, because I have the opposite and I have the adjacent. So tangent of the angle, we usually use theta for an angle. You could have used x if you wanted, is 5 over 10. I'm going to do inverse tangent to both sides, which makes the equation look like this. So on my calculator, I'm going to take inverse tangent of 5 over 10, and I'm going to get just right around 26.6 degrees for that angle. Okay, so that's a good review of sine, cosine, and tangent, solving for side length, solving for hypotenuse, or solving for an angle. Okay, how about our radical review? Okay, this is mostly multiplying radicals. So if we have 4 times 3 radical 5, again, we're just going to do, we have 4 of these, which is really just taking 4 times 3. So that, oh, I'm going to sneeze here. Oh, maybe not. Sorry. That was 12 radical 5, right? Just 4 times 3. Here we have 2 radical 3 times radical 7, so we're just going to multiply the radicals together. So that's just 2 radical 21, and radical 21 doesn't simplify, so that's fine. Here I'm going to take again the numbers with the numbers and the radicals with the radicals, or the roots with the roots. So I'm going to get 20 radical 33, and that doesn't simplify. Here I'm going to get 3 radical 5 squared. Well, that's just 3 radical 5 times 3 radical 5, which is just 3 times 3, which is 9. But then radical 5 times radical 5 is radical 25, which really this is just 5, the square root of 5 times the square root of 5. Hopefully that makes sense, that it is just 5, which is the square root of 25. And then we get 45, so that one worked out to a nice number. Okay, so here's how it might pop up in this situation. Let's say I have a square and the side length is 7 radical 2. Well, I might be interested in the perimeter. Well, the perimeter is going to be 4 of those guys, right? So it's just 4 times 7 radical 2, which is 28 radical 2's. Or you could do 7 radical 2 plus 7 radical 2 plus 7 radical 2 plus 7 radical 2, and you'd have 28 radical 2's. Well, if you wanted the area, don't you really have to do this? Isn't that how you find the area of a square? And so you end up doing 7 squared, which is 49, and then the square root of 2 squared, which is just 2, and then we get 98. So stuff like this doesn't, it pops up in squares and rectangles and Pythagorean theorem and all sorts of stuff. Okay, last thing. Here I want to remind you of the 45, 45, 90 and the 30, 60, 90 special right triangles. So these are our special right triangle patterns that we memorized. We know that every 45, 45, 90 triangle has these exact patterns. The hypotenuse is the square root of 2 times bigger than the sides for 45, 45, 90. And for 30, 60, 90, the hypotenuse is double the small leg, and the long leg is the square root of 3 times the small leg. So let's see how that might pop up over here. Let's say I have a rectangle, and I have the diagonal of a rectangle, and I know that the diagonal makes a 30-degree angle with one of the sides. But if I know this is a 30, 60, 90, then if this is 10, that's 5, and that's 5 radical 3, and all of a sudden, I now know the perimeter and the area. I can do the perimeter because this is 5 radical 3, 5 radical 3. So the perimeter here, so that'd be 10 plus 10 radical 3. It wouldn't simplify. The area, hopefully you can still see this, would just be length times width, which would just be 25 radical 3. Okay, oh, barely see it. And then we can get this. And again, I know this guy went with this guy, right? And then this, we're pretending that this is some square. And if it's a square, I want to know the diagonal. I don't have to do anything other than if this is 7, I know that's 7 radical 2, because I know that a square forms 2 triangles that are 45, 45, 90, and the diagonal must then be the square root of 2 times bigger than the side length. Okay, this isn't a complete review, but I think this does a pretty good job of reviewing a decent number of the algebra things that are going to pop up in this unit.